Welcome to Study Loop.
So here we're going to choose the origin to be the point on the ground directly below the baseball was hit. So we can say that y initial is going to equal 1.0 meters, while y final is going to be equal to 13.0 meters. We can say that vy initial is then going to be equal to 27.0 sine of 45 degrees. This would be equal to 19.09 meters per second. And we know that the acceleration in the y direction would be equal to negative 9.80 meters per second squared, or the acceleration due to gravity, of course. So we can use equation 212b in order to find the time of flight. So we can say that y final equals y initial plus vy initial t plus 1/2 a t squared. This is going to become 1/2 a sub y t squared plus vy initial t plus y initial minus y final equaling 0. So in fact, we can say t, this is a quadratic equation, so we can use the quadratic formula in order to solve for t. So t is going to be equal to negative vy initial plus or minus the square root of vy initial squared, and then this will be minus 4 times 1/2 times a sub y multiplied by y initial minus y final. And then this will all be divided by 2 times a, or in this case, 2 times 1/2 ay, so essentially the acceleration in the y direction. This would be the acceleration due to gravity, and we can solve. So t would then be equal to negative 19.09 plus or minus the square root of 19.09 squared minus 2 times negative 9.80 multiplied by negative 12.0. This will all be divided by the acceleration due to gravity, negative 9.80. So we can find that t is going to be equal to 0.788 seconds, or 3.108 seconds. Now, the smaller time would be the time reached the time the baseball reached the building's height on its way up, and then the larger time would, of course, be the time that the baseball reached the building's height on the way down. So, of course, we must choose the larger result. T equals 3.108 seconds. So this would be your total time. And then essentially, we can say, in order to find the total displacement in the x direction, this would be delta x would equal vx times t. There isn't any acceleration in the x direction, so we don't need to account for acceleration when we are calculating the displacement in the x direction. So this would be equal to 27.0 cosine of 45 degrees. So that would be the initial and final velocity in the x direction, again, meters per second, multiplied by 3.108 seconds. And our total x displacement would be 59.3 meters. You have to round to 3 significant figures. And this is our final solution. That is the end of the solution. Thank you for watching.